All right, hey everybody. I just wanted to show this Hack the Box challenge. I thought it was particularly neat, kind of evil as well. This is SecretRezipe. And the description goes like this. We've launched a startup that produces soft drinks. We use special ingredients to make them very tasty. So we have a lot of protections on our files to prevent our competitors from copying our ideas. When you start this, you'll end up starting an instance, which will give you a host with a port. If you go ahead and copy that and stick it in a web browser, we'll go ahead and do that now. You end up with this website. It's pretty much standard garbage. Lorem ipsum. It's all placeholder text. These people do not exist. And then we have this at the end here. You can enter some ingredients in the following form and they will be appended to our list. Obviously, you will not be able to overwrite our secret ingredient. Our whole business depends on this ingredient and we do not want our competitors to discover it. So the crux of what we've got here is we've got a node.js site that running Express framework on the back end. That's creating a dynamic site that when you click this, it goes ahead and downloads an ingredient.zip. We'll go ahead and grab that. And if we look at the source of this site, which is right here, which if you look at the challenge, you can actually see you can download it right here. If you get that, you end up with the zip file. And if you undo the zip file, you end up with this right here. Now, digging through, you'll notice it really is just a normal node.js application. Node for the uninitiated. .js is a JavaScript dynamic web serving engine. So it will create and display a dynamic website based on JavaScript. If you dig around enough in the source code, you'll end up finding the route, which the routes are pretty much exactly like the virtual URLs within Apache. It basically says, for a given URI, this is what I want you to do. And in this case, this is the important one right here for getting of /. If you try to get /, it's going to go ahead and send you a file, and that file is going to be index.html. And so that's what actually sends you to the main site, which is great. That's fine. But the one that's of real interest is right here, and that's router.post. So if we post to /ingredients, we're going to let data equal secret and our flag. And then if within the body of that post, there is JSON with JSON values prefixed with ingredients, we're going to go ahead and add that to our data along with our flag. And we will go ahead and write them to a file, which is ingredients.txt. And we're going to go ahead and zip those up. And then we'll go ahead and send them out. So we go ahead and send them out. Oops, that's actually not right. It's right here. We go ahead and send those out. And so that's what actually sends it out to you. So within the zip file, what we've got, and it's actually defined right here, we've got a flag, and the zip file is set by a password. If we look at the config.js that's referenced right there, here's your flag, which is read from flag.txt, which of course we don't have that file. So they've been very nice to us, and they've given us a fake flag for testing, so that at least if we run this locally, we can find some flag, even though it's not the flag. So the important thing to understand here is that we've got a password, and this is set by random crypto random UUID. So this is a I believe it's a 32 or a 64-bit UUID. Or it may even be more than that. It really doesn't matter. The point of the matter is that it's set to a completely random value that's practically impossible to crack. Now, that statement's kind of crap. I mean, eventually, yes, you probably could crack it, but It is absolutely not the intended path. There's too much of an investment, especially for just a hacking challenge, for this to be the answer. Sure, you could probably get the answer by cracking the password to the zip. That's not what the intention of this particular box is. So the question then becomes, so we've got a zip file with unknown contents that we need to figure out what the contents of that zip file are. But at the same time, we do not have an ability to uncompress because it's set to an unknown password. So the question then becomes, what can we do to figure out what the value of the contents of the zip file are? And the question really becomes, what can you do within zip if you can't decompress to expose the contents of the file themselves, the file that it's compressing? And what you have to do is you have to consider what it is that zip does as a compression file utility. And what it fundamentally does, and this actually took me way back. This took me back to like my BBS days when I first figured out, because I remember when I first read about like PKZip and the creator Phil, and I read about what he did. It almost instantly washed over me exactly how zip works. And other compression utilities that are similar, because they're all pretty much kind of the same. So how zip kind of works is, let's consider we have 30 A's in a file, right? We just have a file that has 30 A's and a W. So what zip does is it detects redundancy within patterns within your data source. So if you've got, as I said here, 30 A's and a W, there's absolutely no reason that we need to keep all 30 A's because they're just copies of each other. So if we have our 30 A's and a W, there's absolutely no reason to notate that the way that it's notated. What we would probably do is just say A29W to represent the exact same value. Because we've got the original A, and then there's 29 copies of that A, and then the next value after that is a W, which is a unique value. So if we can't decompress, but we can add to the archive, the question is, can we compress something that's already known and find an indicator that'll show us whether or not the value we've added is correct or not? And the answer to all of that is yes. Yes, we absolutely can. If we take a look at the structure of a zip file, you'll notice that we have a pretty standard header here. In fact, I don't know about you, but zip is so common that even if I'm just looking at a binary file being represented by ASCII, like I'm just watching a printout, I can usually detect that there's zip data just because I know the header. I don't even, you could quiz me on it, and I don't think I could tell you what the header is, but I know it instantly when I see it. And it's actually because it's this right here. It's X50, X4B, X03, X04. And so that's always the header. And so that's what it really looks like. And if you notice right here, we have compressed size, which is a header of interest. So if we already just downloaded a zip file. So let's take a look at that zip file, and let's see, what do we got? So we got ingredients.zip. So let's take a look at what it looks like. So this is a hexadecimal representation of the file as we have. And if you remember what that header was, which we'll put it back up on screen here so you can see it, specifically the signature of the local file, which these are known as the magic bytes, is 54B0304. And if you take a look right here, 54B0304. And then if you take a look again at that header file, we'll notice that we've got signature, version, flag, compression, mod time, mod date, CRC32, and then right here, compressed size. It's on the 10 line, 16 plus 2 more bytes. So it's, 16 plus 2 more bytes. So if we look 18 bytes into the header, we'll see the compressed size. And indeed, when we look at here it is. It's actually right there. There's our compressed size. Now, the value itself doesn't actually matter. I don't care what this value is set to at the moment. Because if we go ahead and go back to the site itself, actually, let's go to the source code for a second. If we go to the source code, there's something that we know and can add to test whether or not our theory of, hey, can we add some additional data? And if that additional data is no different than what's already there, it will just increment the count and increment the not increment the compressed size. So what we already know is right here. We know for a fact that it's going to be adding this to that data. So this is literally what's in the file that we're looking at, is secret. This piece right here is absolutely going to be there. We know that for a fact. We can see it right there. And then if we look at the flag, we can see this part right here. Now we know this fake flag for testing is not there because that's not part of the real flag. But this right here, this prefix HTB open bracket is absolutely there. So what we end up with is secret HTB open bracket. So just so we have an additional letter to play with, I'm going to go ahead and take off that. And what we're going to try doing is we're going to try adding secret.htb to that zip file, and let's see how it changes what we end up seeing. So let's go ahead and do that. Secret HTB, go ahead and write the zip. This will create ingredients.1 because ingredients already exist. So we'll go ahead and say yes. And there we go. So what I'm going to do is, let me clear. We're going to XXD. I'm going to bring up the original one, although we're going to seek 16 bytes in, so that'll chop off that top header. And we're only going to look at the next 16 bytes after that. And then we'll look at the original file just so that we have it up on screen so we can see exactly what the old file looked like. So that's the original file. That's literally the zip we got with nothing in it whatsoever. Now, here's the file that we got with secret : space HTB ingredients. Let's see that one. So as you can see, the compressed size has changed. Now the problem is we didn't think it was going to change, but I don't necessarily think that's a problem. And the reason is because we need some overhead to be able to say, hey, there's a different place where this same pattern repeats. So I'm not necessarily worried that this changed. My question at this point is the next byte going to increment or decrement? So what I'm going to do is go back to, where's my text? Go back to here. So we know just by looking at that source file, we know the next flag is, or the next part of the flag is going to be an open bracket. So I actually suggest let's not put an open bracket. Let's go for the wrong answer. So we know the open bracket's the next step in the process. Let's give it an X And we'll see what ends up happening when we look at that field again. So let's go ahead. We'll stick it in here. And of course, it's going to be naughty. There we go. Could have just added the X, but you know, whatever. Go ahead and grab it. And this should create ingredients.2 or ingredients2. And we'll go back to shell. So yeah, it's the shell I was working with. There we go. And go ahead and put a 2 here. And let's see how it changed. Now that's interesting. This is the one with secret : space HTB added to the file. And this is the one with secret : space HTBX. And as you can see, we went from 3C to 3D. We've incremented by 1 byte. Now, if we go ahead and let's go back and try the right answer, which is open bracket, we'll go ahead and take this. We'll copy it. Go back here, paste it. This should create ingredients 3. Now if I look again, ingredients 3.zip. Interesting. So this, ingredients 1 had secret : space HTB, which is only the pieces that we knew are absolutely there. And then we went ahead and added the open bracket, which we also know is absolutely there. And this counter hasn't incremented whatsoever. When we added the wrong answer, which is secret : space HTBX, it did increment by 1 byte. So we can see that there's a difference here. We've gone ahead and incremented by 1 byte when we got the wrong answer. So the mechanism that we see here is that if we go through and brute force this letter by letter, only one of those letters that we try to add will not increment this counter. So whichever one doesn't increment the counter is actually the correct answer. So if we look, I've actually written a Python script, if I can get here. If we look, might help if I looked at the shell. If we look here, that's fine. Here's the solution that I came up with. So I'll just go through it real easy and quick. So import a bunch of junk. I've got a character map that I created. This was easier than trying to just go through all the characters, especially since like null values, etc. There might be something that might be quote unquote bad characters. So I just went ahead and took a reasonable group of characters and put them in a map. Set up some variables for tracing and tracking, and one variable that's of note here, and it's because I named it stupidly, is I called the variable which keeps track of that counter the high score. But the problem is of course, it's actually not the high score. The high score are the wrong answers. This is kind of like the desirable score, or maybe it's not the last score, because the last score could also be the high score. In either case, it's just a bit of stupidity in terms of the way that I named the variables. It's of no real interest. So it just sets up, and what it does here is, honestly, these variable definitions here actually don't even matter, because right here I go ahead and I call for a zip based on just secret HTB open bracket. And the reason I do that is so that I can set a baseline value. I actually had a really hard time when I first started this, because I was trying to do it on a micro level, and I tried just adding like S to see how it changed things. And because it takes a little bit of extra overhead to be able to say, hey, there's another instantiation of this exact same pattern, but somewhere else, because there's a little overhead, I would see the values increase, and I would think I was actually in the wrong neighborhood. I was not looking at the right things. It wasn't until I actually pushed out a bunch of it, until I literally tried all of Secret HTB, didn't care what the values were, but waited until I got this, and then incremented one more to see if it increased or decreased, that I actually figured out that this worked the way I thought and hoped. So we've got Secret HTB. It basically gets a baseline value. It goes ahead and calls the website asking for that zip file. It gets the response, compares it, and figures it out. It then also enumerates the character map and starts up the main loop. And then the main loop essentially does exactly what you think it would do. It starts with Secret HTB open bracket and increments A through Z, everything that's in this character map, checking against whether or not the high score matches, if the high score matches the letter. Because if the current score is higher than the high score, then that's the incorrect answer. If the current score is the high score, then that is the answer. And then there's some other fun stuff in here, like at some point, compress size is somehow getting smaller despite adding data. So I detect that as well. There's a few other fun things in this, and but yeah, that's basically what it does. It goes through, checks whether or not the compress size increments, and if it does, that's incorrect, and we move on and look for the next letter. So let's go ahead and run this. And I need to grab the host. Well, that is definitely not what I was looking for. There we go. Go ahead and grab the host and run exploit. And here you can see it actually working out. It's already got the first letter. When I did this, I actually did the first letter by hand, just as a proof of concept. And I was very lucky that it was a lower or an uppercase C. I started with uppercase, so that was the first one I ended up finding. And as you can see, it's actually going through and it's finding each individual letter in the flag. I also, within my script, I'm not going to show it, but I actually also had a secondary portion. It was very concerning to me that the value, much like I saw in the beginning, the value might go up, and it didn't matter what that value was in the beginning, and I felt like even if the value of the compressed size went up, it still shouldn't matter. Whatever value incremented that counter the least was absolutely the correct answer. So I've actually got a secondary portion of my code that if the value of compressed size goes up, it checks for the lowest value amongst all the letters. And that piece of code actually never ended up getting hit. It actually, the value as you go through it, it's currently at 3C00, and it absolutely never got any higher, no matter how far through the flag we got. The only time it ever got higher is if the flag you guessed, or the letter you guessed in the flag is wrong. And in reality, what we're really playing here, if you didn't realize it, of course, is Hangman. We're just going through and eliminating all the other possible choices until we absolutely have the right answer. And as you can see, this is absolutely leet speak. We're pretty much there in terms of finding the flag. because that spells out compression and leet speak. And in reality, because here it is actually done, it absolutely is correct. So that's how it does it. And what I found really interesting was the fact that you could add to the zip file and leak the contents essentially based on the compressed size. I thought that was particularly genius. The problem with all of this for me is that it's friggin' useless. Because if you were going to face this in a real world scenario, first of all, you're not going to have the ability to add to the zip file, and certainly not arbitrarily in terms of like just adding a single letter. Second of all, even if you are able to add a single letter or, you know, a small amount to the zip file is going to contain much more than, you know, 30, 40 bytes of data. So you're going to have more patterns that it's tracking, that it's actually going to be fairly difficult to determine where and if what you've added is actually unique, or if it's common to what's already there. It's going to be very difficult to tell whether or not that's actually the case. In either case, that's it. And like I said, I thought it was kind of an evil challenge, and it pretty much made me really enjoy. I enjoyed this one a lot. I especially once I actually started counting down and it started going through the actual flag and figuring it out. I very much felt like at the end of War Games when Joshua was trying to guess the launch codes. Anyway, so there you go. That's it. And thanks for watching. Go ahead and click the like and subscribe buttons. And thanks much. Bye.